Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is MEX on ranges. The problem difficulty is easy and there are no prerequisites. Let's have a read out a problem. You are given a zero indexed binary string S of length n. Since this is a binary string, it will only contain the characters zeros and ones. The length is n plus 1. Now our task is to construct a array A that will have the length n. And the conditions for the elements is that the value of S of x is going to be 1 only when if there exists the value of ln(r), that is there exists a subarray in our array A such that the MEX of the elements in this range of ln(r) is equal to x. If that is the case, then the element at of S of x must be equal to 1, and it is guaranteed that we can form the string S and there exists a valid array A that satisfies all these conditions, and we are allowed to print any valid solution satisfying these conditions. So for the input format, we have t test cases, and for each test case, we will have two lines. The first line will contain the single integer n, and the second line will contain the binary string s of length n plus 1. As for the output, in a new line, we have to print n integers going a1 till an, that is a valid solution. As for the constraints, number of test cases will go from 1 to 100, length of array A will go from 3 to 100, and length of string S will be n plus 1. Since S is a binary string, as discussed previously, it will only contain the characters 0 and 1. And initially, the first and the second character, that is S0 and S1, will also be guaranteed to be 1. Let's see some sample inputs. So for the first sample input, the length of our string S is 4. It is 1100. Let's see what does it mean. It means that since S of 0 is 1, it would mean that there must exist a subarray in such a way that the MEX value. Now what does MEX mean? So for MEX, it is the smallest non-negative integer in an array that is missing. So if I have the integers 0, 1, 3, 4 and 5, the smallest non-negative integer that is missing here is 2. So in this case, for S0 to be equal to 1, it means that there must exist a subarray that does not contain the character 0. So let's say if we put something like 2. If I now select this subarray, the MEX is 0, that is the smallest non-negative integer. Now similarly, there must exist S of 1. So there must exist a subarray in such a way that the minimum, the missing number, non-negative, is actually 1. So for that, let's say we put 0. Now if we have 0, and if you select it as a subarray, the MEX value is going to be 1, because in this, all the previous non-negative numbers are already present. Now 3 and 4 are 0. It would mean that we should not have any such subarray who will have a MEX of 3. So if in this case I put a 1 here, right, this is just speculation. Now in this case, what would be the MEX? MEX would be 3, and that would force the value of S3 to be equal to 1. But we can see clearly that it is not the case. So for that reason, we cannot put a 1 here. Similarly, S2 is also 0. So we should not have a subarray where 2 is missing and all the rest of the numbers are present. So for that case, let's put a 0 here as well. Now in this case, we cannot select a subarray such that the MEX is 2 or MEX is 3. Therefore, this is a valid answer. Let's see how we can approach the solution. So now we know that for a MEX to exist, all of its previous number should be present in a subarray. So let's say you want MEX to be equal to 4. I have to mean that in this particular subarray, we must have the numbers 0, 1, 2 and 3. Only when we have these three numbers does MEX4 exist. Now obviously we can have greater numbers like 5, 6 and 7, all those things, but that does not matter. We are only concerned about 4. So for 4 to be the MEX of the subarray 0, 1, 2, 3 must be present. Now we know that S0 and S1 are always going to be there. So for that reason, we can always have 0 and 1. With this, if you select 1, the MEX becomes 0. If you select 0, MEX becomes 1. So let's say for an example of 5, let's see what we can do. Now if we have, let's say 2, 3, 4, and let's assume this is the case, right? Because anyway, the S is going to be of length n plus 1, and array has to be of length n. That's it, right? So in this case, all the MEX can be found. If you want MEX to be 1, if you want MEX to be 0, just select any subarray and 0 will be the MEX. If you want 1, we have 0 that we can use as a subarray, 1 will be the MEX. If you select 2, 0 and 1, 2 will be the MEX. If you select 0, 1, 2, 3 will be the MEX. You get the point. Now let's say we don't want 3 to be a MEX. What can we do? Now, if we don't want 3 to be a MEX, we need to make sure that if you are choosing a subarray, 0, 1, 2 are not present there. Even better if 3 is already there. So for that case, what we can do is we can simply swap 2 and 3 places. So if we do that, let's see what would happen. Now we have something like this. Now for MEX to be equal to 3, we need a subarray that has 0, 1 and 2. So let's try to form that subarray. I have 0 and 1, and now I also want 2. So to reach 2, I'll have to cross 3. And with this, now my MEX has actually become 4. Now similarly, what if I also don't want my MEX to be ever equal to 4? That is, I want my S of 4 to be equal to 0. Again, we will do the same thing. We'll simply swap it with its previous number, right? Now if we swap it, this becomes 0, 1, 3, 4 and 2. Now again, if you want all the numbers, right, 0, 1, 2, 3 to be present so that MX can be 4, to reach that, we'll have to cross over 4, and with this MEX will actually become 5. So this will also not work, right? So with this, we now successfully understand what is the condition to make any S of I equal to 0. So what we are going to do is, initially we are going to have our array as 0, 1, 2 till n plus 1. So with this, all the MEX are possible. Now at any point of time when you want to make S of x to be equal to 0, what we'll do is, we'll simply swap it with its previous number. So with that, we will never be able to form the prefix of 0 to S of x minus 1. Since we cannot form this prefix, we obviously will never get the MEX value of x. And with this, we'll get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and then we take the input of our string s. Now as we know, s has the length of n plus 1 and our array needs to be just of length n. So for that, what we are going to do is, we are going to initialize our array of length n plus 1 so that we can accommodate all the indices, and we initialize it from 0 to n. So with that, we can have all the possible MEX and we can have their respective prefixes that we need to reach that MEX. Now for this, what we are going to do is, since we know that S of 0 and S of 1 are always going to be 1, we start checking with S of 2. So if S of t is equal to 1, we simply skip it because we want to have that as our MEX. If we reach any index where we don't want that to become an MEX, what we are going to do is, we are simply going to swap it with its previous number. Once we do that, we will not be able to form the required prefix to get that MEX value. And as you can see at the end, we'll print our n integers, and we have gotten EC in C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and our string s. With this, we form our array that will be from 0 to n. Then again with this, since the existing array that we have formed, with this we can form all the MEX. We then try to search for s of zeros. Any index where s value is 0. Once we find that, what we do is, we swap it with its previous element so that we cannot form the required prefix to get that value as a MEX. At the end, we print this resultant array, and as you can see, I've got an EC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement this in both C++ and Python. Have a very good day, and I'll see you in the next video.